Okay, this is section 8.1, graphs of the sine and cosine functions. This will be pages 3 and 4. Not much math to do on page 3. There is some stuff that we want to make sure you're comfortable with, so this will go kind of quick. Amplitude is basically the height from the midline. So when we talk about the amplitude, we're talking about strictly this piece right here. Okay. 2 times the amplitude is the difference between the maximum value and the minimum. So anywhere we've got a peak here, anywhere we've got a value, we're going to define these same way we do with any other functions. This will be a maximum value. Just so happens that in periodics, oh, that is not an M. Periodic functions, you have the same maximum happening over and over, and then we've got our minimum down here. If we blow this up, you can see that as the amplitude increases, so there are functions, the black is 1 sine x, the blue is 2 times sine x. We double the max, right? Because that's what that multiplier does. It doubles our outputs. And so when we talk about amplitudes here, I really am only going to deal with the zeros, the maxes, and the minimums, and then I'm going to go ahead and create that sine curve or cosine curve by connecting the dots. Trying to graph square root of 2 over 2, or square root of 2, or square root of 3 over 2, you're more trouble than it's worth. Don't even worry about that. Notice that as a gets bigger, as we go from 1 to 2 to 3 to 4, the height of our graph gets bigger. Okay, so that's what our amplitude is affecting. That's going to be a vertical stretch. That's what the amplitude is telling us. On to the second example here, if the absolute value of a is less than 1, so we're dealing with a fraction that is less than 1. Notice here that the black curve is still 1 sine x. Now our blue curve is 1/2 times the sine of x. Our green curve is 1/3, and our orange curve is 1/4. So it's taking that output, it's multiplying by that fraction. This is going to be a vertical compression, right? It's not going up and down as much as the normal. Okay. Last thing we definitely want to talk about, if a is less than 0, so before we were talking about the absolute value of a, if a is actually negative, it's going to do what you think it should do. It's going to reflect across the x-axis of the function. Now, when I say it reflects across the x-axis, that is before we translate vertically, up or down. Okay, so we're reflecting across the middle. Then if we've got to translate, we're going to move up and down after we reflect that. So on to page 4. Okay, we kind of cranked through this on the first page, just plugging into the formulas and chugging away. Now let's talk about what these mean. We're going to talk about what the period of a sinusoidal function is. So for now, we're going to ignore C and ignore D. We're going to ignore that component of the phase shift, and we're going to ignore the vertical shift completely. And so we're looking at functions that are just the basic. A times the sine of bx or a times the cosine of bx. The period here is 2 pi over b. And so the period is the amount of time it takes for a function to repeat y values. Okay, so again, a here, g of x equals the cosine of x over 3. Remember that x over 3 can be written as 1/3 times x. So now this is my b. If I want the period, it's still 2 pi over b, which is 2 pi over 1/3, which is 2 pi times 3 over 1, 6 pi. What's going to happen to our function is that instead of happening over 2 pi, here's our graph. So here's our original function. with a period of 2 pi. Here is our new function. Here is g of x. Let's find a different color. You notice here, we now have a period of 6 pi. Okay, so we start at that 0, we hit a max at 1, we go back to 0, minimum of -1, and back up to 0 in the span of 6 pi now instead of 2 pi. Okay, there's the period part. Example 5, we've got the horizontal and the vertical shift. So a horizontal shift is called a phase shift. Okay. We found that on the first or second page by dividing C by B. Notice here, if we rewrite that, if we factor that B out, we can set this up so that you can pull the phase shift right out of the equation. So you may see these written both ways. You want to be really careful about whether there is parentheses between the b and the x, and the b is being multiplied by the x minus whatever, or if it's not. Okay, so when we factor that b out, we get an argument, or inside the argument, we get that set of parentheses that looks like x minus c over b. That tells us the phase shift. Because when we did transformations in college algebra, that minus was a pretty big deal. X minus c over b means that this tells you which direction you're going. If you have a minus in front of the c over b, you are moving to the right in the positive direction. If you've got a plus in front of it, we think about that as rewriting it as a minus negative c over b. That's going to move it to the left. Okay, that's it for pages 3 and 4.